Welcome guys, welcome to our another video. In this video, we will be talking about how to take a GIS map or the raster data set into the Python programming and calculate the numerical analysis. So stay tuned with us. Again, this is our another project for our master's course. So my other teammates will be conducting the video too. So let's get started. Let me share my screen first so that you can see what's going on here. So this is the project we will be working on. We are working on to present in front of you. In this project, we have taken the land use data from a website, from national website for United States. In this project, we will be analyzing a definite part of this map. Like you can see that these you can see this map has different colors, and if and each and every individual colors represent a definite land cover. For explaining, let me show you the website. Like each of these land use have a predefined definition. Like the green colors will like you can see that green colors will represent the forest area, the gray color will be for barren area. In this project we will take into account the only about on the planted or cultivated area, that would be green and gray. Okay, so this is the map for land covers in Texas, and we will be working on these two categories. Like we will only calculate the total area that is covered by pasture or covered by the cultivated crops. So let's get started. So first of all, we need to import the data we have downloaded from the website. For that, we need the OS library. As you know, if you see our previous videos, we will be clear why we need OS, that is operating system library. And to read that or work on that, we will need NumPy, we will need GDAL, we will need and to plot some maps and graphs, we will need matplotlib. And to work on the arrays, like to count them and to calculate the total area, we will definitely need the array. So that's why I have imported 6 from the libraries. So let's jump into the code. First of all, we defined a we defined a character like fn to name our data. This is our data, the directory for the data. We defined it as fn, and then we wrote this set of command just to open the data so that GDAL can or Python can read it and explore it. So let's run this one. Actually, it will not show you, it will not be visible because I have not written any command to show you guys, but it has been done. And to check that, I have written this block of codes. Like what is the type of this data, you can just write this way, that the type ds. Here ds is our data set. So so if we run that, we can see that it is a GDAL based data set, and it is a GDAL based data set. So we can explore more furthermore with these block of codes. Like we can explore the projections. Projection means how a data set is arranged on different perspective, from different perspective. And with this code, like the raster x size, we can define sorry we can get the total number of columns, total number of rows, and even we can count the band numbers. So that is what we have done in here. We get that number of columns, number of rows, and the projection properties in here. And then we will be defining the array, because without the array we cannot just deal with numbers. So we need to deal with the numbers, we need to calculate the numbers. That's why we are trying to define the array. And to define the array, we actually just converting the raster data into an array so that we can deal with the numbers. So you can see this a block of codes, that is get raster band dot real raster array read as array. So the final data is stored as data array, and we can see that how what is the value or what is the shape of this data set. So mm, so in here it is there are only two figures. You must be wondering what are these two figures. It is just the number of rows and the number of columns. This is number of columns, these are the number of rows in our data set. So if whenever we get we get the number of columns and number of rows in the full data of the full map, that means we can multiply them to get the calculate the total area. So that's what I have done in here. Like I have multiplied rows by columns, so I get the total area of the total area of Texas map. Mm, and then we have converted you have converted the we are sorry, we are just trying to see that the like we have converted it the data set into an array, and we are trying to see if the code really works. So we to ensure that we were checking the data array type and found out that this is a numpy array, like the previous one. Like the previous one, when we checked and that this data set was a GDAL based data set, now it's a NumPy array, so we can deal with numbers right now. After converting array, I wanted to see how many classes are in there, right? I have mentioned previously that there are different classes in the total map, and they are classified on the basis of land use. So we just wanted to see how many classes do we have, and like we were counting, or we were this block of codes will go through each pixel, each square block, to see what numbers are in there. Actually Python cannot read the color, so whenever we are converting this map or GDAL based data set into an array, this is attributing some numbers to against that color. So yeah, let's say minus 128 is green. So whenever it goes to a cell and finds it's green, it marks as minus 90, minus 128. That's what is happening in here. So we have a lot of cells. You can see that we have a lot of cells, so we cannot eventually see all of them. So we have we have written a code to find the unique numbers, like in this map how many colors do you have. So in for that we have defined defined a as our unique characteristics of data set. So after writing this code, numpy gave us the unique numbers. So what unique numbers do we have in this data set? So we have got these numbers, and now as I have told you earlier that we are only dealing with 81 and 82. We want to calculate how much area that is covered by cultivated crops or hays, and how much is the percentage, like what is the percentage of hair planted or cultivated crops in comparison to the total area. So these two colors bears the numbers of 81 and 82. So in this problem or in this project, we will be dealing with only 81 and 82. So that's all from my project mate will take it over now. See you guys, happy learning.
Hello friends, welcome to my video and my name is Naidu. Okay, let's jump into the video. My friend explained all this part regarding this code of the determination of area from land cover maps of Texas. So from now, I need to explain this plastered cultivated land 81 and 82 and how to extract the data and how to plot the maps in the Jupyter notebook. Okay, let me show you the code. Let's jump into the code, guys. Here we go. Okay, first of all, we need to extract the pixel data of pasture or highway. So here I'll take it a as a constant, that is data array 81. Here you see the one, 81 means pasture or hay. 82 is cultivated crops. And here pasture means the grass area, which is useful to animals feeding of animals and sheep. And cultivated land means used for production of annual crops like such as cotton, mirchi, or anything, vegetables. Okay, we need to extract the data from the system. So here, extract the data of pasture, and I'll name it as A, that is equals to 81. This will return elements that satisfy condition B. So now I print the elements that satisfy condition A. Here, elements that satisfy condition A is equals to 81, right? Then I named it as B. B is equals to np dot extract A comma data array. So type of B, we need to find it B type. So here type of B is equals to numpy dot nd array. So elements that satisfy condition A. So now I need to find the length of the numpy array B. So I need to print the elements that satisfy condition A is equals to 81. So I'll write the code for it. Here you see. Then the elements satisfy condition A is equals to 81 is equals to 75432950. This is the value. The number of elements is equals to 75432950. Like that, and I need to calculate area of pasture. So here area 81 is equals to, we got the value right, 75432950, and area is equals to the value of a pixel into the size of the pixel. Size of the pixel is 30 into 30. Length is 30 and width is 30. So I need to print this pasture of hay area. Pasture or hay area is equals to, I get the value 678896. I got a numerical value. So then this is the area of the pasture. So now I need to extract the data, pixel data of cultivated crops. That is equals to, I take it as C is equals to data array, that is equals to 82. This will return elements that satisfy condition B. Then I need to print the cultivated crops area. Oh, no, pixel data. So here I need to print elements that satisfy condition A. So then the elements that satisfy condition A is equals to 82. 82 is cultivated crops. So D is equals to np dot extract C comma data array. Type D. Here we see type D is equals to numpy dot nd array. Then I need to find the length of array of crop elements. Then print elements that satisfy condition 82 is equals to, we got the, by running this one, by running this code, we got the value of 94867328. This is the C. This value is, this is the number of pixels that satisfy condition C is equals to 82. Then I need to calculate it area of cultivated crops. Here we see area 82 is equals to 984. We got the value 94867328 into 30 into 30. Here is also same, 30 into 30, width into length. Then we got the, then we print the cultivated crop area, that will be 853805952. Then print D type. we got numpy.nd array. From this onwards, we need to plot the graphs. We completed the pixel data, like pixel data of cultivated crops and pasture, and then next we calculate the area of pasture and cultivated crops. Then here we need to plot the graphs of pasture and cultivated map. For plotting maps, plot dot figure size is equals to 10 comma 10. The size of the map will be 10 comma 10, and plot dot im show data array 82. First we plot the pasture data, pasture map. So that is equals to, by running this code, we got this map, which is showing the grass area of pasture, grass area in Texas. Then after, we need to plot the graph for cultivated crops. Then plot dot figure size is same 10 comma 10. Plot dot for array 81. Then by running this code, we got this map. Here we see the cultivated area, which is useful for cultivation of crops like any corn, cotton, like that, the annual crops like this. Okay. From this, the raster data sets, I need to tell you something. These raster data sets will be useful for attributes in tables. They can be displayed with your geographic data and are used to convey additional information about map features. A common use of raster data is in a GIS as a background display for the other feature layers. These raster data sets will be useful to calculate area and pixel sizes and plotting maps in GIS. So I think this is a very useful information to us. So thank you, friends. Have a good day.